architecture group over at Netflix. So we're the team that, sorry. Over at Netflix, my team was in charge of moving all of the data science systems up from data center when we were just a DVD company back in the day into the cloud, where once we started streaming, I think Netflix really got onto the map for being a company that deployed in AWS 100% of the business. And as far as big data goes, a lot of cloud-based Hadoop stuff came out of there. And so that was a lot of fun working over there. We were running several 1,000+ node Hadoop clusters on AWS through EMR. Some of those were persistent, some not. Running.
Yeah. The microphone looks pretty good.
There we go. Sorry about that, guys. Try not to hurt your ears. So we had several 1,000+ node Hadoop clusters over there running. It's tough to remember from a year ago, but over 10,000 MapReduce jobs per day. So pretty decent scale. Something like 3 to 4 petabytes of data that we were crunching through at any given time, all backed on S3. So a lot of fun. And then, come about 9 months ago, some of my former colleagues over at Netflix had moved a while back to this startup doing a personal styling service for women called Stitch Fix. Back when they started it, we all thought they were crazy, but they started growing a little bit, hiring out a really cool data science team. So really great people to work with over there, concentrating on the combination of machine-driven recommendations married with human computation, right? So perfecting that space of machine-driven and then human-curated decision-making on top of it. So you can kind of think like a mechanical Turk model of algorithm and recommendations, but the difference being that the humans, instead of just anybody coming through mechanical Turk, are expert humans on our platform, right? So pretty unique opportunity there. Lots of data again and lots of algorithms, but a space that is a little less tapped, where you can invest enough in each recommendation coming out that a human gets to see it, right? So we get to figure out, what is the machine best at, what is the human best at, and how can we exploit that relationship the best way possible, right? So 2 big data roles in very different spaces, one for a very well-established company and another for a startup. And so, what I'm here today to do is to talk about my experiences building these big data platforms and, trouble spots that we ran into operationally and from a user's perspective, and things that we've done at both companies. I have a team of 5 people over at Stitch Fix. I had a team of between 5 and 10 over at Netflix running the Hadoop ops. And at both companies we've got at Netflix 200 to 300 users on that platform. Over at Stitch Fix it's about 100. So we're supporting all of those people with very little resources. So specifically what I'm in charge of is data platform engineering. And if you boil that down to a charter, it's to make data accessible, easy to discover, and easy to process for everyone in an organization. So that's, I believe, how you succeed in building a data platform. And so you look at the users of a typical data platform, and they span anywhere from analysts, who are typically pretty non-technical. They deal with typical BI tools or reporting technology, all the way over to pretty hardcore engineers, right? And if you look at what they're interested in getting out of your platform, engineers, they want really good API layer, right? They want to integrate the data into an application back into the business that they're building. Analysts, they want a really rich tool set, so they don't really care about the machinery behind the data, they want the results. But everybody, both of those groups want something self-service. They don't want the platform engineers to be roadblocks on the path to the big data. They want something simple to use, They want it to be transparent, right? They want to know what's going on with their job and where it's at, how it's been submitted. And they want a single point of reference to get to all of these big data systems, run their jobs, and get their results back. And so you look at the common problems that come up when you're submitting these jobs, and a lot of the questions that I would get. Like, I'm an engineer at heart, and as we deployed these platforms for people, you've got to support them, right? And so, as one of the few people that actually knew the internals of how this stuff worked, I would get a lot of questions, right? And this was, one of the primary questions I would get is, people would come and they'd say, like, I don't understand what the heck my job is doing, right? And I would get so sick of answering this question, right? Because I don't know what their job is doing either, so I'd say, let me see it, right? And then it's like this 2,000 line pig script. We use pig over there. And so this is what a typical pig script at Netflix looks like. And I blurred it out because,
that's how they do recommendations, by the way.
yeah.
You may want to take a picture of the slide right now.
Yeah, if you could unblur that, then maybe you'll learn some of our secrets. But it is a real pig script over at Netflix, and honestly, like, this is just a portion of it. You can see it's several hundred lines, right? And so for me to understand what their job was doing, I'd have to understand what the heck this is doing, right? And then I could help them debug it. And so, they're the experts in the domain of the data. They understand the data science. I understand the platform that it runs on. We need to have a good conversation with each other. And starting from this point, it was painful for them. It was painful for me. And so I went about trying to solve it. And this is what I came up with. We call it lipstick for pig. And so it was a lot of fun. It's got a pretty cool logo. I forgot to put it up here. But anyway, lipstick for pig generates out of this, right? Logical explain plan, and then creates it graphically on the screen, right? And so the explain plan looks something like this. We annotated the blue boxes, dark blue boxes are map jobs, orange boxes are reduced jobs, and then the blue bounding boxes are map reduced jobs that the script compiles into, right? And as your script runs, the boxes will flash depending on what phase they're in. They'll update counters across the screen. And when people don't know what the heck their job is doing, when you can see it logically, or not logically, but graphically as a DAG, right, things become a lot more obvious, right? And so this is all open source. There's links to it a little bit later in the talk. But if you're running Apache Pig, if you're so fortunate to be doing that, this is a pretty cool solution. It's been used to monitor, at the time that I had left, well over 100,000 jobs over at Netflix, so it's pretty battle tested. And you can see, all of a sudden when somebody is able to say, I don't know what my job is doing, we would say, well, what's the lipstick link, right? And it became so familiar over Netflix, they'd say, well, do you have a lipstick for that, right? And so people would start emailing these links around instead of the scripts, and we'd be able to have a lot better support conversation, right? Your job is doing this because, maybe you're misjoining two fields or, whatever. So the next problem that we come to get is, I can't figure out why my job failed, right? You would get errors in Pig that look something like this, right? And this is across 3 files. The top line is what comes out on standard error, right? Then you dig into the first thing, right? And then you get this error in the middle. It's like unable to open operator for alias ring, right? You dig in a little bit more into the actual MapReduce task, and they'll throw this error that you get a NPE at limits.java line 44. Right? And so you still don't know what the heck's going on unless you're me and you wrote the slide, and you do, right? And so to help debug with this, again, lipstick to the rescue. When jobs fail, it turns your job red, right? And it can annotate on the graph things that are happening, right? So here we see you've got 216 rows came into this job and 0 rows come out, right? And this isn't actually a graph of the error up at the top, but had you seen a graph of the error at the top, you would see that you're passing 0 rows into a rank operation. Pig doesn't like that, and so it crashes, right? And so that error that is so obscure when you just see the stack trace becomes really obvious when you build visibility around it. And fun problem number 3 is, why is my job running so slow? And this can creep up for a couple of reasons. I'll have questions later. So why is my job running slow can happen for a couple different reasons. And we had a different tool that we built for this one called Invisio, or Inviso. I could never pronounce it. But basically it's a tool for exploring performance of your job and your cluster, right? And so if we were to pull up a MapReduce job on Inviso, this is what we would get, right? So this is examining all the map and reduce tasks by a single job. And so I didn't actually write this tool over there, but you can see they stole my blue for map and orange for reduce. That's how my legacy lives on. And so you see here a timeline of all the tasks, and then time is to the right here. And so all the map tasks ran pretty consistently across time, right? And you see a bunch of reducers. Most of them didn't do much at all. They finished in like a little fraction of a millimeter of time there. But some of these reduced tasks ran on forever, right? And this is a huge indicator of data skew, right? You've got like 5 reducers that are doing something and the rest of your reducers aren't. That's kind of tough for a lot of people to find. Here it's pretty obvious what's going on. You can mouse over each of these individual plots on the graph here and you'll get the counters for the job and things become a lot more obvious. So that's an actual problem with your job itself, right? You ran it against skewed data. What can happen where your job usually runs fast, the data is fine, your job's healthy, is that your entire cluster can be unhealthy, right? So it's often important to see, what is the state of my cluster in context of when this job ran. So Inviso could do that as well. We can see here, this job was running during this window, highlighted in gray. And you can see a graph here where the big peaks are number of pending tasks that need to run, right? So queued up tasks. And then the other 2 bits there are allocated in reserved slots on the cluster. And so what you don't want to see are these big spikes, right? Because it means a whole bunch of work was queued up and you didn't have enough capacity to run it, right? And so being able to see this across time, you can see 2 things, right? One, when your cluster is over allocated, right? And 2, when it's under allocated. So really you just want to be running this at 100% peak capacity all the time, which is what we would try to do at Netflix, right? You wanted 100% usage of all of your resources, otherwise you're paying for something that you're not getting your money's worth out of, right? But you don't want these big wait times, right? Because then data just starts getting backed up. You get a backlog of jobs that you're never going to finish, right?
Do something kind of like to smooth out those, to increase the size of the cluster using conservation?
Yeah, so at Netflix we would look at this data and as a quality of being on EMR, we were able to actually like expand and contract our clusters very elastically, right? And so that's how we would start smoothing things out, is we would add capacity dynamically when we got these peaks, right? And when we found the troughs, we would give back capacity. So the way Netflix works, all on the cloud, right? So we've got thousands of instances that are reserved, right? Some of those instances are allocated to engineering to serve front-end web traffic. Some are allocated to encoding, to encode new movies to entertain you, right? And then some are allocated to the big data clusters to compute recommendations and things, right? And so we would split capacity between those 3 groups as demand needed it, right? Like obviously front-end got first dibs, right? But encoding and algorithms would play with each other. So that's how we would use this graph.
Can you hold your mic closer to your mouth?
Yeah, sure. Well, I'm almost done now. So last graph here just shows, this can show you more than just number of tasks that are reserved, but we can look at this across all kinds of dimensions. And so here we can see across different classes of applications, so we would tag our applications by type. You got up here ETL and something we would call Ursula, which was event capture application. And so you can see here, based on the amount of memory allocated across the cluster for those 2 application types, right? Like how much memory they were allocating over time versus other things on the cluster, right? So really great tool for ops, really great tool for users to come and serve themselves. And both open source, right? So even though I'm no longer there, I do love to get stars and forks on GitHub, so you feel free to come and clip us. Sorry. Not hard to find. Lipstick and Inviso under Netflix OSS. But so what is not so great about this, right? If you're not lucky enough to run pig in your environment and you want that kind of lipstick visibility, right, you'd have to build it yourself, right? And it's really hard to keep track with the evolving pace of technology, right? Like if you want to switch from pig onto Spark ETL over at your deployment, right? Then all of a sudden you're going to sacrifice a lot of that visibility, right? So it's tough to keep track of or keep pace with the speed at which data tools are evolving. And a lot of good open source software exists, like Lipstick and Inviso, but it's not the only tools we had over at Netflix. And again, you know, a lot of that still isn't open source, which is a shame, but you know, some of it is so embedded in other technologies in the business that it's hard to tease apart, right? So it's not that Netflix wouldn't necessarily want to give it away, or other companies that build it, LinkedIn, Twitter, they all open source a lot of great tools, but a lot of their tools, you know, are hard to bring public, right? So it's not comprehensive and it's not a one-stop shop. So you could probably stitch these things together, right? But still, you know, they don't flow between each other as well as you would like them to. And I know this from experience now. At a startup, trying to steal these tools from the work that we did over at Netflix, you know, it's hard to get an environment that's cohesive when you don't write it yourself or, you know, bring in something. So, you know, we've also got limited engineering resources in a lot of places, right? So where are you going to prioritize your effort? Is it on this raw infrastructure, or are you going to prioritize effort to something a little more business specific? And you know, my hiring dilemma is, you know, it's really hard to find people that understand Hadoop internals at a low level, right? So if you want to bring in people that can solve these problems and build these tools, they're tough to hire. So that's it for me. I'm going to hand off the mic to
Thank you,
Noel.
Jeff.
I'm gonna try this.
Give you a minute.